Did you know light can bend so much it creates a million-dollar illusion in the sky? That's right. Rainbows are nature's most dazzling trick. Today we're explaining light refraction at 5 completely different levels, from curious kids to wise seniors. And by the end, you'll see rainbows in a whole new way. Let's start with the youngest explorers, ages 7 to 11. Imagine you're at the playground, and suddenly a rainbow appears in the sky. Here's the magic. When sunlight hits raindrops, it bends, just like when you dip a pencil in water and it looks broken. That bending is what makes a rainbow appear. Each color in the rainbow is like a different stop on a rainbow train. Red, orange, yellow, green, blue, indigo, violet, all lined up in order. And guess what? Every rainbow is different. No two people see the exact same one. It's like nature's own personal masterpiece. But there's so much more to discover. Let's move up a level. Now we're talking to teenagers, ages 12 to 15. You already know that light bends in water, but did you know it also bends in the air? That bending is called refraction, and it's what makes a rainbow form. When sunlight hits a raindrop, it slows down and bends, and each color bends a little differently. Here's a surprising fact. Double rainbows are rarer than winning the lottery. That's because the second rainbow is formed by light bouncing twice inside the raindrop. And even more fascinating, some rainbows shimmer or flicker. Scientists still can't fully explain why that happens. Now let's take this even deeper, into the world of high school physics. For ages 16 to 18, we're diving into the science. When light enters a raindrop, it slows down and bends. This is refraction. The angle is always around 42 degrees from the direction of the sun. This precise angle is why you can only see a rainbow when the sun is behind you and the rain is in front. It's a perfect alignment, like a cosmic game of tag. Scientists use this principle in optical experiments, like splitting light into colors using prisms. It's the same idea, just with glass instead of water. And here's something cool. This concept is used in fiber optics, the technology that powers the internet and modern medicine. But in the real world, this gets even more interesting. Let's go full adult mode. For adults, light refraction isn't just pretty, it's powerful. It's used in everything from lasers to lenses, from cameras to contact lenses. In medicine, refraction helps doctors see inside the body, like in endoscopes, where light is guided through tiny tubes to illuminate organs. In engineering, it's used to design everything from car headlights to solar panels, all optimized using the same principles that make rainbows. And in technology, it's the reason your phone screen looks clear and bright, thanks to anti-reflective coatings that use refraction to reduce glare. And finally, the perspective that changes everything. Let's go to the seniors. For seniors, light refraction is more than science. It's a journey. From ancient philosophers to modern physicists, we've been trying to understand it for centuries. In the 17th century, Isaac Newton discovered that white light is actually made of all the colors of the rainbow, a revelation that changed the world. Today, we still don't fully understand why some rainbows shimmer or why they vanish so quickly. A reminder that even in old age, there's always more to learn. And what does this teach us? That wonder never fades. It just deepens with time. And scientists still can't explain why some rainbows shimmer. But that's what makes them so magical. From kids to seniors, rainbows remind us that the world is full of wonder, and that science is just the beginning. Which level surprised you the most? Comment below, and don't forget to share this video with someone who loves rainbows.